Hi, my name is Lingling Fan. Today I'm going to present our recent work about large-scale modeling of low-emissivity films for energy-saving buildings. According to the Department of Energy, about 30% of US energy is related with building operation, and in between there is a 40% that is directly related with HVAC systems. So it is very important to maintain sustainability from engineering those raw materials because building walls constitute the main component of the building thermal envelope. So on the other side, you can see that the stable temperature is very important. On the first hand, the thermal comfort is important for human functionality and health. And in the second part, it is very challenging because the external environment varies dramatically throughout the year, so that in those hot environments, we have a huge demand on cooling, and in those cold environments, we have a huge demand on heating. So the key of our sustainable building material design is to engineer the emissivity of the radiator so that we can change the heat transfer process. So to design the optical property of our building wall material, we need to consider the solar irradiation and room temperature thermal radiation, as we show in this figure. And as a result, we designed this colored low emissivity film on this figure, and it is fabricated using a very simple process and is very compatible with the large scale commercialization. And spectrum of our design is that on the first side, it shows very high reflectivity, which corresponds to the low emissivity in the mid-infrared range, so that we can reduce a heat transfer. And in the second part, the reflectivity of this visible range is also engineered for those visible purposes. In order to evaluate this performance on a large scale, we use this Energy Plus software and simulate across the United States. And you can see from this heat saving map, about 140 gigajoule can be saved by in those HVAC system by installing these low emissivity films. So it's very promising and can bring a huge difference in our current HVAC system. Now we would like to introduce some of the details of our modeling. For example, in those cooling conditions, the main purpose is to reduce the heat gain, whereas on those heating conditions, the main purpose is to reduce the heat loss from the indoor environment. As a result, we can solve for those energy saving, and it agrees very well with those simulations. To conclude, we have developed these low emissivity films, and it works as simultaneously with those desired colors. And in the second part, we simulate and evaluate the performance of our material in a very large scale, and it can save a lot of HVAC energy consumption by installing our materials. And thank you for your time and attention.